the opportunity to play around with it. So we've got the new 1 3/4 hose, the Fire Equip Master Flow, which is actually 1.88. So it's got a little bit wider girth as far as 1 3/4 goes, less friction loss, but it's designed in a way that it's should be able to handle lower pressure operation with less kinking and stuff. With the flow test kit, what we can do is be able to see exactly what our flow is going into the truck. We're going to keep our tank pump and our research closed off so that what's going in is what's coming out. We've got, the kit came with inline pressure equipment. So what we do is we put one at the end of the pigtail, one at the 100-foot mark, and one at the tip. And what that's going to let us do is we're pumping, we can, first of all, we'll be able to see what our discharge gauge is coming off, and then we'll be able to look at that first gauge, and that's going to tell you how much friction loss and plumbing loss there may be between where that pickup is for the pressure gauge and the end of that pigtail. Just give us a baseline of how much pressure we actually lose in the plumbing, and then the 100-foot mark will be able to take that number, subtract this first number, and that will give us our actual friction loss per 100 for that hose at that flow rate. Friction loss is based on flow rate. So the more we flow, the higher the friction loss goes. So that's all kind of got to be kept in mind. You can't just say your friction loss for this hose is X pounds per 100, because as you goose up the pressure, especially on these nozzles, the friction loss goes up with it. So we'll be able to tell our plumbing loss, our friction loss per 100. We'll fine tune figure out what it is to make sure, theoretically on our nozzles, we should be getting about 75 PSI at the tip, regardless of the pressure. It should compensate to hopefully give us a 75 PSI tip rate. The reason I've got the smooth bore on there now is the first thing we want to do with brand new equipment. It came calibrated from the factory, but really the only way to truly calibrate these is to compare to a known flow, and the only way we can have a truly known flow is going to be to use that smooth bore to pitot it. It's got a 15/16 on there, so when that hits 50 PSI, we should be showing 185 on the meter. If we're not, then we'll have to go through and calibrate it. But once we have that flow rate calculated, we can pop that back off, pop our nozzle back on, and then we'll be able to play around with some different pump discharge pressures to see kind of where we fall in line between the pump discharge pressure, the flow rate, and to make sure that it's maintaining that pressure at the tip that we want to maintain. Does that kind of make sense? So in doing that, once we have those numbers calculated, we can also calculate for what the reaction force is, which is kind of what we're the amount of pounds of force that's coming back, which is based on the pressure and the flow rate. Nothing we can really do to control reaction force other than either reduce flow or reduce pressure. And in the case of the automatic nozzle, reducing one reduces the other as well. So we want to maintain a reasonable reaction force that leaves the line manageable and able to be flowed right. So that's really the first step. I kind of came up with a little worksheet that we can kind of keep track of all that as we go, and as we familiarize ourselves with it. Mainly this is the first time we've actually got this out to play with. Wanted to get comfortable with that, kind of get comfortable with the process. That way we can kind of open it up on a wider scale with more stations and shifts, and be able to really, ideally what we'll have is at the end is we'll be able to figure out, is the plumbing loss different for different trucks, or is it averaging out the same? Depending on what our target flow rate is, we can come up with a pump chart for each truck that's very specific to that truck, as far as if you want to maintain 175 GPM out of this line, flowing this hose with this nozzle, your pump discharge should be X. And that can be different from truck to truck. We can get as fine-tuned as we want, or we can average it all together and kind of try and have more of a system where we're just kind of playing on averages. But that's kind of depends on the direction we want to take with it. It's up to us. Any questions?